Okay, let's continue our discussion about block cipher theory. First of all, we will explain a method which called Feistel Network or Feistel Cipher. In fact, it was a general way to encrypt some blocks. In Feistel method, we have a sequential runs, okay? And our block is divided in two parts, left and right. We have also a function f which is used in each round, and we need also some keys. Depends on the number of rounds. Those keys are derived from the overall key count. Okay? Let's see what happened in Feistel Network. I explain on the diagram. Here you can consider that our block is divided into sub-block. Right, which is shown by R, and left, which is shown by L. We have also a function. As you can see here, we map the right block into left block, and the left block is a function of fi XOR by a key and put in R1, as we can see here. In each iteration, Li is exactly the Ri1 minus 1. L1 is equal to R0. L2 is equal to R1. And for Ri, we have to execute function f on the right side of the previous section, XOR by Li minus 1. Here R1 is equal to F over R0 XOR by L0, and so on. Here R2 is equal to F2 over R1 Ri minus 1, which is R1, XOR by L1. Okay, and L2 is equal to R1, and so on. Okay, the interesting point here is that this network is reversible. What does it mean? It means that you can use the same mapping function to decrypt the cipher text. And here is the formula. In fact, you need to start from here in the vice versa direction. Okay? In fact, you swap between right block and left block. So simple. This is the interesting point of this method. Okay. I hope everything is clear for you. This is the general transformation or mapping for encryption, and in the other side you need to do the inverse method from I to E to reach to one step before till reaching to the plain text here. Okay, this is the interesting point of the Feistel method or network, in fact. And it is essential that it is important to know that we need to use the function from end point to start point, from the last function FD till the first one, in a reverse order. I guess it is clear. Okay, this method is used in many block cipher encryption like AES. Okay. Anyway, here you can see some points about Feistel Network. For instance, increasing the size, the block size, improves security, but clearly which leads to slow ciphers. The same thing about the key size. It is essential and it is clear for you. It's increasing the key size will increase and improve security. But the number of rounds again, but as you can see, increasing any item which cause a slow cipher. Increasing and improving security, but a slow cipher, decreasing the time and make complicated to produce your ciphertext. Again, the complexity for making subkey make cryptanalysis much more harder, but again slows cipher. And greater complexity can make analysis harder but slow cipher for round function also. And finally, it is essential that fast software encryption or decryption and ease of analysis make more practical solution and make testing more easy. Okay, the last part of this lecture is introducing about this method. In fact, this or DAS is a kind of Feistel network with 16 rounds. The input block size is 64, the same for output block size. Here, before using the round of Feistel network, we have some IP here, some method for permutation, and on the other side here we have the reverse method for permutation. Please think about that. If these two steps that are added in this make it possible to have a good encryption scheme, please think about it till the next lecture. Thanks so much for your attention and for your time.